Our last video here in our rational numbers unit, Unit 3A, is least common multiple. And our learning target, I can find the least common multiple of two or more numbers. Our vocab here, a multiple, is a product of a number and any whole number. And the least common multiple, or LCM, of two or more numbers is the least of their common multiples, excluding 0. So you should have both of those vocab words written down. So just like with greatest common factor, there's two methods that we can use here to find the LCM. The first one is to list the non-zero multiples, so the numbers that they multiply into. So we're looking at 6 and 10 here. So for 10, the multiples, it's like as if you're skip counting by that number. So 6, 12, 18, 24, 30, 36, 42, 48. Now you just kind of go for a while and then stop and then start with the other number and see if it lines up, and then if there's not, then you just have to keep going until you find the smallest multiple that they have in common. So now for 10, 20, 30, 40, 50. Well, if I look, I see that 30 is the smallest multiple that they have in common. So the LCM, or least common multiple, for these two would be 30. The other method, just like with greatest common factor, is to do the prime factorization, so the factor trees. So 6 is 2 and 3, both of those being prime. So 6 equals 2 times 3. Now with least common multiple, when you're doing this method, you write them in exponential form, so they're written with exponents, but in this case there aren't any, so we just write it like this. 10 would be 2 and 5. Now, for least common multiple, you look at every number that shows up. So I see we have a 2, a 3, and a 5. And you would take each number to the highest power if they had exponents. So we would take every single number. So we take one of the 2's. We take a 3 and a 5, and we multiply them together. So 2 times 3 times 5. Well, I know that that is 6 times 5 is 30. So LCM equals 30. So either way that you do it, you end up with the same answer. So we're looking at the least common multiple of 45 and 75. So again, you could list out the multiples for them and find the smallest one they have in common, but this is a little bit more difficult with higher numbers. I know 45, 90, well, I know if I add another 45, that's 135. It starts to be kind of a lot. And then if you were to do 75, same thing. So I'm going to do the factor trees. The prime factorization method. 45 can be split into 5 and 9, 5 being prime. 9 would be 3 and 3. Both of those are prime. Now in this case, with 45, we have 3 twice, so we are going to write it with exponents. So 3 squared times 5. Now we do the prime factorization for 75. Well, 75 would be 5 and 15, 5 being prime. 15 would be 3 and 5. So 75, again, write this with exponents. So 3 times, now 5 shows up twice, so we write it 5 squared. Now, when we are picking numbers, we pick the numbers. We pick every number, so a 3 and a 5, but we pick them to the highest power. So between the 3's, 3 squares higher, and between the 5's, 5 squares higher. And that's what we would now multiply. So 3 squared times 5 squared. Well, 3 squared is 9, 3 times 3. 5 squared is 25, 5 times 5. And then 9 times 25. If you think about quarters, it would equal 225. So that would be your least common multiple for 45 and 75. And it kind of talks about how we solve it down here. Okay, here's some for you to try or follow along as I go through them. If you feel comfortable, though, pause it and try it. Better than just sitting there and not doing anything. At least give them a try. So for 3, well, that one's already done. It's already a prime number. So the prime factorization of it is just 3. You can't split it up at all. So for 12, we can split that into 3 and 4. 4 splits into 2 and 2. So 12 equals 2 squared times 3. So we have to take each number to the highest power. So I see that there's a 2 that shows up overall and a 3. Well, we can only take that 2, and both the 3's are the same, so it doesn't really matter. And then we multiply all of that together. 2 squared is 4 times 3 equals 12. Least common multiple is 12. Lowest multiple that they have in common. 10 and 12. 10 splits into 2 and 5, both being prime. 2 times 5. 12 splits into 2 and 6. 6 splits into 2 and 3. So writing with the exponents, 2 squared times 3. So throughout this entire part here, I see a 2, a 3, and a 5. So I have to take one of each of those numbers to the highest power. So between the 2's, the 2 square has the higher exponent. Then there's only 3 and 5, and that's what we now multiply together. So 2 squared times 3 times 5. Well, 2 squared is 4. 4 times 3 is 12. 12 times 5 equals 60. Least common multiple would be 60. 25 splits into 5 and 5. Both of those are prime. 5 squared. 30 would split into 5 and 6. 6 splits into 2 and 3. So for 30, that would be 2 times 3 times 5. So we look at every number that shows up between there, 2, a 3, and a 5, and we take them to the one with the highest exponent. Our only option for 2 and our only option for 3, between the 5's, the 5 squared is higher and has the higher exponent. So I multiply 2 times 3 times 5 squared. So I know 2 times 3 is 6 times 25. 25, 50, 75, 100, 125, 150. Least common multiple equals 150. And again, you could have listed them. So you could have listed 25, 50, 75, so on and so forth, and then 30, 60, 90, so on and so forth. And you would eventually find that the smallest number that they have in common is 150. Either method will work. If you have any questions or if you're still confused, go back, rewatch the examples again, try them on your own. Otherwise, do some IXL practice too, and then come to class with questions.